My name's Alan Hart, and in today's video we're going to do some fault finding on the Baxi 80, the Baxi 100 and the Baxi 133 HE Combi boilers. I'm here with Roy from Viva Training Academy. He's going to go through this hydro block here, going to show us the components in it. He's also going to show us how to test it with a multimeter. This video today is absolutely amazing. If you could, please put a comment below. And please put a thumbs up on the video. Be really grateful for that. Without further ado, let's go over to Roy.
Thanks, Al. Hi guys, it's Roy Fugler here at the Viva Training Academy over in Halifax, and today we're going to have a look at the hydro block out of the Baxi 80, 100, 130, 133 HE Combi. Been out quite some time. It's the one with the aluminium heat exchanger. Originally started in the Baxi Barcelona and eventually ended up as the Baxi Solo heat exchanger. There's quite a lot of these boilers out there, so we're going to have a look at the hydro block in detail. We're also going to do a little bit of multimeter on there. We've got some cutaways so you can see how it works. We'll go through plate heat exchanger, diverter valve and all sorts of things like that, so hopefully it'll be of use to you. So without further ado, let's make a start. So as we can see on the rail, we've got a slightly different arrangement to what Baxi usually have. Usually Baxi's, the return's on the right, the flow's on the left. On this one, we've got the return on the right, then the flow at the side of it, the PRV's on the far right, and then we've got the cold water inlet and the hot water outlet. So as you can see, on the return, we've actually got a mesh filter in there. Now, when I was out on patch as a Baxi engineer, one of the main things I went out to was those filters getting blocked, customers complaining of the boilers overheating, the radiators not getting warm, and it's something that not a lot of people realised there was a filter in there, and they used to get blocked up because we're talking about days before we put filters on systems and we started flushing systems out. So it's always one to check for, is the filter in there. Just as a word of caution, these isolation valves are prone to leaking when you're turning them on and off. The good thing about them is we've got a little drain point on them, so it's quite easy to drain the boiler, but I personally don't like turning those isolation valves off because I have had them leak in the past. With it being a system, sealed system, there's no reason why you can't take the pressure out of it and then it'll airlock, so you don't really need to start isolating it. Just take the pressure out, and that way it'll get around turning those off, because we don't want to open that can of worms of we've gone to a fault and we've created another fault. So that's something to look at. So coming across onto the cold water inlet, so the cold water inlet's got a very similar mesh filter, and it's also got a flow restrictor. It's the usual little plastic flow restrictor, so you've got two pieces of plastic, one inside the other with a rubber o-ring, and under pressure that inner piece of plastic pushes on the o-ring and it squeezes it out, and that's what restricts the flow. So again, if the customer's complaining about low water flow, poor water pressure, boiler cycling in hot water mode, that's always something to have a look for in there. So we've got a standard efficiency, because this was way before ERP, Grundfos 1560 pump. Now again, one thing to look out for on these boilers, on the larger ones, the 133s and the 100s, you could put an external pump on there because they were designed for larger systems. So you could have a situation where you've got a second pump on that system. Now in the wiring diagram, you'll be able to find on there where that second pump connects in. So it's worth just double checking if there's a second pump on the system. So what we'll do, we'll take the plate heat exchanger off. So it's just four screws, 4 crosshead screws. Now, obviously, I'm in a workshop, I haven't got my gloves on, but one of the things with plate heat exchangers, just be careful with them, because a lot of times the plate heat exchangers can be quite sharp. This one's pretty smooth, to be honest, but it is something I usually wear my gloves when I'm taking plates out, because I have cut my hands in the past. So we've got the third screw out, so that one popping out, and then we're just onto the fourth one. Now in the real in the real boiler, it won't be wobbling about like it is on this rig that I've made up. So we've got the plate heat exchanger out. So as we can see, we've got the connections on there. So I'll just pop that down. So as we can see, the cold water comes in and it goes through a paddle switch. Now these boilers have got 2 paddle switches on. There's one on the main heat exchanger, which is a pump proving switch, and they work on the principle of a little magnet. So basically inside there, there's a little paddle that moves. A little bit later on, I'll get the multimeter out and show you how you can test them. It's just a simple matter of popping your probes in there. There's a little mini plug, so you can unplug it, pop your probes in, and then all we do, we can check that switch. We'd normally turn the water on, but I'll show you a little trick just to prove that the switch is operating a little bit later on. So cold water comes in and it goes into that manifold, and then obviously it goes through the plate heat exchanger, comes across and goes back out on the hot. So the primary water's coming down in here, going across through the diverter valve, and then it's obviously it's going out on the floor, out round the radiators, coming back and up through there. So I'll just pop those screws down. So the diverter actually has a cartridge in it, and the head, literally, there's a little clicker underneath. So, and it's quarter of a turn, that pops out, and all we do, we just unplug it. So that's the diverter motor. So you can replace the motor, the diverter cartridge. So we're going to pop that out. Now, a replacement cartridge, you normally pick those up and they come with a little key to remove them. Now obviously it's a lot easier for me doing it in the classroom in here down at the Viva Training Academy than it would be out on the field, because on the field the boiler's not going to be at a nice height, it's probably going to be in a cupboard. So I do understand that. So these keys, they come with them, and all you do is just pop that in, and then literally you just unscrew it. And obviously this one, I've got it all set up just to make my life a little bit easier in here. So we can then unscrew this, and we've got a cutaway. It's a cutaway at the back. So what we'll do a little bit later on, we'll zoom in so you can see operating the motor. So that's the cartridge. Now, this isn't the cartridge that came with this boiler, and I'd just like to say thanks to George Drake, my mate, who's donated this boiler to us for me to strip down and pull it in bits. Now this was one George took out because the customers were complaining they got intermittent problems with hot water. They'd also got a few water leaks on it. That's the actual cartridge which came out, and as you can see, it's broken. I had to break it to get it out. It's seized up, it's sticking. So that's the cartridge. Now what they do, they move in and out, so you can see that moving up and down. So as it moves across from heating to hot water. So what we'll do a little bit later on, we'll get it all back together and we'll get out to zoom in so you can see that moving in and out. So that's that section there. The pump, it's a standard Grundfos 1560 head. My opinion, bad place to have the electrics. It'd be better on the top. Obviously if we get a leak from there, it's going to go into the electrics. But you've just got 4 bolts to remove that. We've got a cutaway on the side, so we'll zoom in to have a look at that. So what we'll do now, we'll pop it back together, and then we can show you some of the ways that it works. Right, so what we've done now, we turn the hydro block around on the jig, just so you can see where the cutaway is. So at the moment, we're actually sitting in hot water position. The primary water would come down into this port on the back, so it comes down off the main heat exchanger into here, and it can go through into this part of the cartridge, and then down through this pipe all the way onto the plate heat exchanger, back through the plate heat exchanger, and then returning through the pump up to the main heat exchanger and coming back down. So we're open there to the hot water port, closed off to the heating port. So if I now just flick the switch, we can see the cartridge is moving across, closing off the hot water port, opening up the heating port. So inside the cartridge it's open, so the water can flow through the cartridge, through into that port there, and up through, up round the heating, down out on the flow pipe. Again, round the circuit, through the radiators, coming back, returning through to the pump. Again, up out of this port here, up to the main heat exchanger, picking the heat up, coming back down into this section here. So that's basically how the cartridge works. So it's always close to one of the ports. So if you're getting a problem, the customer's complaining, usually in summer that the radiators are starting to get warm, what's normally happened is there's some dirt sitting on the inside of that cartridge seat, and it's not fully closing that port off. So that's one of the problems. You won't get that situation in winter. They're not going to complain about the heating coming on in winter because they want the heating on. So it's normally going to be in summer. What they're going to be complaining about in winter is the hot water performance. And again, I think I said on a previous video about diverter issues, we know that the water on a combi boiler is not going to be as hot in winter because the water coming in and out the road is colder. So sometimes we assume that that's the reason. But there are ways of checking it. We can check across the plate heat exchanger. We can ask the customer to leave the heating off before we go out. So we're going out to a cold boiler. Then when we put the hot tap on and we can feel the flow pipe starting to warm up, we can then sense that obviously the cartridge isn't closing off properly. And it is something that happens on this type of cartridge. These are used on quite a few other appliances. There's all sorts of different boilers are using this Honeywell cartridge, so it is quite a well-known cartridge, and it does suffer in dirty systems, which we used to get. A couple of other things about this. If you do get one like I had, which was quite jammed in, you can actually replace this top section, the one where the motor clicks onto. That section is available as a spare. There's a seal which goes in between the two halves. So you've got the main pump hydro block and then the diverter section. Something else to watch out for, as you can see, the two connections that are going onto the plate heat exchanger and down onto the float, they've got O-rings in. And those pipes are held in by little self-tapping screws. Now, something that can happen, you start to get a little bit of a water leak as the O-rings start to deteriorate after a few years. And those little self-tapping screws start to corrode. And I've seen them where they've actually got that badly corroded, the water pressure has actually started to push the pipe out, and you're starting to get a drip coming out. Now, sometimes people assume that it could be the plastic hydro block that's causing the problem, and they put a new hydro block in, and it cures the problem because they've put new screws in and new seals. For the sake of a couple of screws, it's always worth checking that. A couple of other little points, you've got some O-rings on the back of these two little brass ports. In all honesty, I don't know what they're for. They're not used on this particular model. I've not seen them used on any other model. But because there's an O-ring in there, there's always the possibility that that could cause a problem. So I'll just recap over that. So at the moment, we're closed off to hot water. So if I flick the switch, as you'll see, the cartridge moves across, closes off the heating port, so the water can't get out there. So it's coming in through the cartridge, down there, and away through the plate heat exchanger. What we'll do now, we'll spin it back round, I'll get the multimeter out, and we'll show you some quick little tips and checks using the multimeter. Right, so I've got my multimeter set up. The first thing we're going to have a look at is this paddle switch. So it's a switch, so when we're testing switches, we do it dead testing on ohms. So before we do any multimeter work on any boilers, if we're going to be doing dead testing, which is ohms or beat testing, always make sure of safe isolation, TB118, always refer to that. We've done videos, so you can look at those. So the first thing I'm going to do is turn the multimeter on to the beat test. I'm also going to pop the light on just so that it's a little bit easier for you guys to see. So if the customer's complaining that they've got no hot water, one of the things that we can do is disconnect the plug from the other side off the main wiring harness. And obviously in a real boiler, the plate's going to be in the way, but that lead sits up there just above the plate, so you can actually get in there. So all we do, just pop the probes up there, don't force them in, just nice and stable, and then we get the customer to turn the hot water on. So I'll use my little pinky to simulate the hot water, and obviously we get the beep, it comes on, and shuts off. So we know that that's working. Now obviously we've gone out and they're saying they've got no hot water. So if that works and it doesn't go any further, we're looking at the next stage, which is potentially the wiring harness going up to the PCB or the PCB. But more likely, we're not going to get the beep when they turn the tap on. It's because there's a problem with that sensor. And I did say I was going to teach you a little tip. So my little tip is get yourself a magnet, and I've got a magnet on the end of my screwdriver. And all I'm going to do is just place the magnet up on top of the switch. And by placing the magnet on the switch, I'm actually making that little magnetic switch. The paddle's not moving up. My magnet on the end of my little torch is making that switch. And you can use that same check on the pump proving switch on the aluminium heat exchanger. So that's just a little tip there about that one. So the next thing I'm going to do is swap the multimeter onto the ohms scale. So we could be getting issues with customers complaining about the central heating not working. We've already talked about the return filter. But it could be the pump that's starting to cause problems. The pump could be slowing down. The pump could be causing us some issues. So what we might want to do is just check the resistance across the pump. So on the little switch, into the middle, the light's popped off because it's timed out. So I'll just pop my little light back on. And then all I'm going to do is just go into the top two connections. And as we can see, we're getting a resistance reading in there of 186 ohms. Well, a Grundfos 1560 pump is normally somewhere around about 168 ohms. That's its base reading. So within 20% of that, within about 20%, so this pump would probably be viable if it didn't have a dirty great big hole in the side, which we've cut. So that's just a way of testing that. So the next thing we're going to do is do a little bit of live testing. So I'm going onto volts. Now, to get into the connections on the back of this diverter motor, my probes are a little bit big. So I've got myself some needle probes. So I take the little clips off. So these are little needle probes which allow me to get into little tight areas without damaging things. So the idea is I can get those probes in. So on this one I've got a blue, a brown and a black. The blue is neutral. So I'm going to pop the black connection into there. And I'm going to go on to the black, the black one. So we're into the black. And I'm getting 0.54 of a volt, just over. So I'm just going to turn that on. And lo and behold, 243 volts. So that's moving across. So we can see we're getting power across on there. So that's moved over. So I shouldn't have anything blue to brown. About 13 volts as a backfeed. So if I flick the switch again, 243. So I can see that's moving across. Now before I got my multimeter out, what I could have done is actually, as we said before, we've got a little clicker so we can pop that out and we can turn this up and down. So at the moment that's free, so that's moving freely. So we just turn it back on. We'll hear it click when it moves across. That's clicked in. That's become solid now, so that's not moving. Turn it back over. And that little arm starts to become loose. And that's just another way of testing these types of diverters. We can also unplug it and do a resistance test on it. So that's just a little tip on using these. So I hope you've liked the video. If you have, put a thumbs up, give us some likes. If you've got any questions whatsoever, please ask. If there's anything you want us to do regarding videos here at the Viva Training Academy in Halifax, please let us know. We're more than willing to do that. We've got some really good things coming forward, some testing on live boilers and things like that, so that's great. So until next time, it's been Roy Fugler at the Viva Training Academy over in Halifax. So bye bye.
Thank you very much for that. I hope you found this video of some use. I've learned a lot on this video myself. I think these videos are absolutely amazing. Please, if you could, as Roy said already, please put a comment below. Yeah, give us some feedback. Tell us if you like this type of video and what type of video we could do to help you even more. That'd be really good. yeah, thank you very much. Thanks for watching.